Hello and welcome back everyone. So today we are going to discuss the second practice problem for stacks and queues, and we're discussing next greater element 1, Leetcode problem 496. So let's quickly go through the problem statement first. It says that the next greater element or some element x in an array is the first greater element that is to the right of x in the same array. So right now I'll not read the rest of the problem statement where it defines two arrays, one is a subset, and we need to find answer for the smaller subset of the array. So instead we'll first try to understand and solve a simpler problem of just finding the next greater element for each element in an array. So the problem of finding next greater element for each element in an array states that we are given an array, and let's say that the numbers in the array are actually 3, 1, 2, 4, and 5. Now for each element we have to find the first element on the right which is greater than the element itself. So for 3, the first element which is greater than 3 and on the right of 3 is 4. So the answer for 3 is 4. For 1, the element on right and greater than 1 is 2, and for 2 it is 4, for 4 it is 5, and there's no element on right hand side of 5 which is greater than the element 5 because it's obviously the last element. So the answer for 5 is going to be -1. So for an array, we have to find an answer array or output array in which the element is replaced by the next greater element, or simply we have to find the next greater element for each element in that array, and the answer for this particular array looks something like this. Now we actually use a monotonic stack for solving this problem. A monotonic stack or a monotonic queue is nothing but a normal stack or queue where all elements are stored either in non-increasing or non-decreasing order. The name sounds a little complicated, monotonic, but it is the concept is really simple. It's a very normal stack or a queue, and there's a certain ordering between the elements. So for instance, if I am saying that this is a monotonic stack and all the elements will be stored in a non-decreasing order, so the elements can be something like this. But the next element would not be smaller than any of the previous elements, so you cannot put 1 here. So then in this case, this will not be a monotonic stack, or you cannot put -1 or any value smaller than 2. So the next value can only be greater than or equal to 2. So if this kind of ordering is being followed, then we'll say that this is a monotonic stack. So the algorithm that we are going to use here is that first we parse the array, we pick the elements one by one. Now what we do, we check if current element is greater than the top of stack. Now there are two possibilities, either it is greater or it is not. So in case the answer is yes, that it is greater than top of the stack, and let's say that the current top of the stack is x. So we'll do two things. First, we'll pop x from stack. We'll replace the next greater element for x as the current element. So the current element will be the next greater element for the top or x which we have just popped from the stack. So once we have done this, we'll again go back to this particular step A. So we are going to repeat this till the time our current element is greater than the top of the stack. In case it is not greater, so in the case where it is smaller or equal, in that case we will break out of the loop and we will push the current element to the stack. And once we have done this, then we'll move to our step 1 and we will move on to the next element and repeat the same steps for the next element. Now this particular algorithm ensures two things. So first, it ensures that all the elements in the stack are always pushed in non-increasing order. So that is why we are saying that the stack is monotonic. It also ensures that an element stays in the stack as long as we have not encountered an element greater than the stack element. So once we reach an element in the array which is greater than some stack elements that were encountered earlier, all those stack elements will be popped from the stack and we'll update the next greater element for them. So let's walk through an example. Let's try to dry run this algorithm on an example, and then it'll be really clear that why we are following this algorithm, why it actually works, and how does it ensure the two things that we have just discussed. For the example, let's say that our array is 10, 6, 5, 4, 9, 4, 11. And let's also take a stack, the stack which is the monotonic stack or the stack we are going to use for creating our answer. And finally, let's also create a helper array or an answer array. So this is nothing but in this array we are going to store the final answer that we are going to return. So basically we are going to store the next greater element for each element. So right now the next greater element for each element will be initialized as -1, and finally as and when we'll find a next greater element for any element, we'll update the value, and all those elements for which we were not able to find the next greater element, their value will be stored as -1 only, which is the final answer, because it says in the question for all the elements whose next greater element does not exist, we need to return -1. So we will start parsing the elements in the array one by one. So right now we are at 0th index and our stack is empty, so we do not have to do anything in step 1. We'll skip step 1 and we'll directly push 10 to the stack. After that we'll move to the next element, which is 6. Now again 6 is not greater than the top of the stack. Top of the stack right now is 10 and 6 is not greater than it. So we will simply add 6 to the stack. We'll skip the step 1, we'll add it to the stack, and then we'll move on to the next element, which is 5. Now by the same reasoning, 5 is also not greater than top, so it has to be simply pushed to the stack, skipping the step 1. Next we'll come at 4. Again 4 is smaller than the top, so skipping step 1, we'll push it to the stack. Moving on to the next element, which is going to be 9. Now also one thing that we can notice is that our stack has been following a non-increasing order. So our stack has been following that monotonic trend right till now, and this trend will continue. Let's see how it works. So now our current element is 9, which is greater than the top of the stack. And step 1 of our algorithm says that if the current element is greater than the top of the stack, so we pop that element which is at the top and we replace the current element as its next greatest element. So the top right now is 4 and 9 is greater than 4. So 4 will be removed or will be popped from the stack, and we will update the next greater element for 4. So the next greater element for 4 will go at this particular index. So this value will be updated to 9, as 9 is the next greatest element for 4. Similarly for 5, 5 will be popped and 9 will be the next greater element for 5. So 9 will be updated here. Again for 6, 6 will be popped and 9 is the next greater element for 6. So 9 will be updated in this array. Now the top of the stack is 10 and 9 is obviously not greater than 10. So we will break out of step 1 and simply push 9 back to the stack and move on to the next element, which is 4. Now what we can observe here, so we can clearly see why the stack is monotonic, because as soon as we encounter a number greater than the top, we pop the top of the stack, and that actually makes sense because we have got an element which is greater than the top, so we do not need to carry the top any further. This ensures that whenever a number is pushed to stack, the numbers below it will be greater than this number. Because if any of the numbers remaining would have been smaller than the current element, they would have already been popped. And the only reason they are remaining is because they are greater than the current number. And also the numbers still remaining are the ones which have not yet found an element greater than themselves. So that is the reason we can say that our stack will always follow this monotonic order. Now 4 is again smaller than the top of the stack, which is 9. So simply push it to the stack and move on to the next element, which is 11. Now 11 is greater than 4. So the next greater element so first of all 4 will be popped and the next greater element will be updated to 11. Similarly 9 will be popped. Next greater element will be updated to 11. Now the remaining top is 10. when 11 is again greater than 10. So 10 will also be popped from the stack and the next greater element will be updated as 11. Now the stack is empty, so we will end step 1 or we will break out of that loop and simply push 11 to the stack. Now our pointer will go out of bounds of the array, so we have complete our traversing. So whatever array finally is left, whatever values we are left in the answer array or the helper array, this will be simply returned as the answer. And you can see this is actually the correct answer. So for 10, the greatest is the next greater element is 11. For 6 it is 9, 5, 4 it is 9. For 9 it is 11, for 4 also it is 11, and there's no greater element or next greater element for 11. So the value for 11 is still -1. So now let's discuss the time complexity for this algorithm. The time complexity for this algorithm is actually big O of n, where n is the number of elements. So now you might think that there's a loop within a loop, like we are parsing the complete array, and within that also there's a while loop where we are checking if the top is less than the current element, then we are popping. So there are two loops, so it looks something like this, like there's a for loop for parsing the array, and within this for loop there's a while loop. This while loop is responsible for handling the step 1 of our algo where we are checking current element and top of the stack. So to understand the complexity or to get the correct complexity for this algorithm, let's go to the very basics. Time complexity is essentially the order of the number of times an operation is performed. So the simple atomic operations which we are performing inside these loops, the number of times these operation will be actually performed is essentially the time complexity. So the operations in the loop are essentially push, pop, and updating the answer. So these are the three operations we are going to perform in all these three loops. So let's try to see how many times we perform these operations. So let's write down which operations. So popping from the stack, pushing an element to the stack, and updating our answer array. Now for updation it is simple enough. The updation of answer will take at most n times, once for each element. So this is going to happen at most n times. Now each element at max is pushed once into the stack and popped out once. So because once an element has been popped, it is never pushed back to the stack again. So the total number of pop operations at max will be n, and the total number of push operations at max will also be n. So the total number of operations in all the iterations of all the loops is going to be 3n at max. So the time complexity for this problem is going to be big O of 3n, which is same as big O of n. Now the space complexity is simple enough. The space complexity is also big O of n, because we are using helper space here, which will be of size n at max. And by the helper space I'm referring to the stack, and the maximum size of the stack at any point can be n, which is the total number of elements in the stack. And this worst case where the size of the stack will be n will be in the case where we have been given an input array which has been sorted in descending order. Otherwise the stack size will always remain less than it. But yeah, big O complexity is the worst case complexity, so big O of n will be the space complexity. Now, if we are clear with this particular question, then the current problem is really easy. Because in the current problem, we do not need to return the next greater element for each element. So what has been given to us is that we have an original array, and then we have been given another array which is the subset of this original array. So in the smaller array, some elements have been picked at random. So let's say that from this original array we have randomly picked three elements, 10, 9, and 4 in the subset array. Now what we need to do, we need to return an array of size 3, or same as the size of the subset array, and in that array we need to return the next greater element for each of these elements, and the next greater element has to be written on the basis of original array. So in the original array, the next greater element for 10 is 11, so 10 will be replaced by 11. The next greater element for 9 is also 11, and 4 is also 11. So what we need to do, we need to return this array as the final answer. So what we simply do is that we find the next greater element for each element in the original array and store it in a map. So we'll make a map like the key will be the value in the array, and the value in the map will be the next greater element. So key will be 10, the value will be 11, key will be 6, value will be 9. So in that way we'll create a map, and then we parse the subset, check for next greater element for that particular element, and from the map we place it in the answer array. So let's quickly go through the code for this problem. So the code is simple enough. As we said, first we'll make a map. So we have initialized a map, and the key in this map is integer, which is the value in the array, and the value in this map is also an integer, which is the next greater element for that particular value. And we have a stack because we are going to use this stack to find the next greater element. So simply, first thing that we have to do, we have to make a for loop for parsing our original array. So also, just one thing, so there are two inputs in this method, which is nums1 and nums2. So nums2 is the original array and nums1 is the subset of nums2. So we make a for loop to parse each element in nums2. And for each element, as we discussed, we do the step 1 of our algorithm. We check if the stack is not empty, and if the current element is greater than the top of the stack, then what we do, we replace the next greater value for top as the current element, because this particular element is greater than the element at the top. So we have found the next greater element and we update its value, and then we pop the top from the stack, because we have already found the next greater element for this current top. So we do not need to carry it any further, and we remove it from the stack. Now once we are done with this loop, so the remaining state of the stack will be that either it will be empty, or the top element will be greater than the current element, greater than or equal to the current element. So once we are done, we'll push the current element to the stack, and we'll move on to the next element. So we'll keep doing this. Now finally in the map, we'll have the next greater element for each of the value in the array. So we simply parse the subset array, and we check in the map that whether we were able to find the next greater element for this current element. If we were not able to find the next greater element for this current element, we simply place -1 as directed in the question. But if we were able to find the next greater element, then we replace the value with the next greater element for that particular element. Once we are done updating the next greater value for each of the element in the subset array, we return the subset array. So I hope that you've understood the algorithm, the logic behind the algorithm, and also the code for the algorithm. In case if you still have any doubts, please feel free to mention in the comment section. And as always, I'll try to address all the doubts. And I'll see you in the next video. Till then, stay tuned, keep learning. Bye bye.